Hello everyone, my name is Ryan coming to you from the DL Academy, and in today's video we're going to be making a hand digit recognizer using TensorFlow. Make sure to subscribe to the channel and let's get started. Alright, let's start our coding. So open a Google Colab page by typing Colab on your browser, and here let's just click on create new notebook. All right, so this will just create a new fresh web page for you so that you can start coding. All right, here, the first thing that I want to make sure is here go on runtime and click on change runtime type. And then here, hardware accelerator, you just have to select GPU for better performance. All right, let's click on save. Perfect. Now we can start coding. So we first start, as usual, by importing our useful libraries. So we'll just type in import TensorFlow as TF. We're also going to be saying from TensorFlow .chars import datasets. We also need layers, and we need models with an S. We're also going to be using NumPy, so import NumPy as NP. Now to run the code, all you have to do is click on this run button on the left, and this will run the code for you. All right, perfect. So as we can see, the code ran successfully, and now I should have an autocomplete function. Perfect. All right, so let's first start by initializing our labels and our features. We're going to be using the popular MNIST dataset. So let me go on Google and type in MNIST, which is a dataset for hand digits recognition for a bunch of, wait, hold on, let me try and find a good picture for you. So this is what it looks like. It has a bunch of handwritten samples, all right? And all of these are 28 by 28 pixels of either black and white. So it's not colored, it's just black and white. So here, what we're going to be doing is we're going to be saying X train, comma, Y train, and then separate to another tuple. We're going to be saying X test, comma, Y test, and this is going to be equal to datasets dot mnist dot load data, and this function will just return the X train, XY, X test, and Y test, and we'll save it in these variables. So we can run it, and as you can see, it's downloading, and it should have downloaded the data. So we can print the data if you're interested, but I'm pretty sure it's very long. It's a big table, so let's just print the first element to see what it looks like. All right, and this is what it looks like. So we know already that it goes, so basically when there's no pixel, it's a 0, meaning here it's a white, and when there is something written in black, there is a value going from 0 to 255. We can also print the shape to see what the array looks like, and as we can see, it's 28 by 28, and we have 60,000 sample of them. All right, so let's add a bit more code and start manipulating our data so that it's actually usable by our model, so that our model can actually use it. All right, so we don't like to have data that goes like from 0 to 255. We're rather in machine learning and AI to have data that ranges from 0 to 1. All right, so what we're going to be saying here is we're going to be saying X train, comma, X test. All right, let me type it correctly. Test. Seems like I can't type today. Equals, and then here X train divided by 255. And these are NumPy arrays, I believe. So you can divide by 255 or by any integer. And then here X test divided by 255. And what this does is this result will be assigned to this variable, and this result here will be assigned to this variable. So we just divide them by 255 each, both the training and the testing samples. Now let's add a bit more code and we'll do some data manipulation. So we're going to be saying xtrain here is equal to np.reshape, reshape like this. We want to reshape our xtrain, and then for here as the tuple, we want it to be 28 by 28 by 1. So this is how we need it to be for our convolutional layer. And since we require, TensorFlow requires us to input 4 dimensions, here put a -1 so that the NumPy library will automatically assign this value for us. So here it should be 60,000. We could either manually input 60,000 or put -1 and let the program figure out what number should come there. And then here for xtest, should basically do the same thing. So np.reshape, and then here xtest, and then here -1, 28, 28, and 1. And this is very important because we are using convolutional layers at the beginning of our neural network. So we have 2 convolutional layers, and I also made 1 dense layer. So the goal of the convolutional layer is just to extract basically features from the image, meaning like it will recognize patterns. For example, the 0, it could recognize like or here a 6, it could recognize like there's a O here, and then like there's a curve at the top. So that's what the convolutional layer is for. And the dense layer is just for a normal neural network. So it takes those and then it applies the biases and the weights to actually create the neural network. And if you don't understand how neural networks work, we actually have a course on our webpage. You can also learn about it from our YouTube channel, of course, but you can go on the dlacademy.com and have a completely free machine learning and AI course. Well, let me wait for the page to load. So this is our website right here, the dlacademy.com, and you will find a full course absolutely free about machine learning. If you're interested to learn the concepts that I'm talking about, like convolutional neural networks and weights and biases. And yeah, so we have a couple of videos for you to enjoy. All right, let's get back to this. Now that this worked, we can actually start by creating our model. We say model equals models.sequential, like this. So there we go, we have created our model. And let's start by adding our layers. So we'll say model.add, and then here we'll take our layers and then conv2d. So convolutional 2D. This, for example, here you can always read. They have information for you. Okay, so it doesn't say it here exactly, but it's used for image recognition. All right, so for the filters or the connections, we're gonna put 32. And then for the kernel size, here we're going to create a 2x2 kernel. All right, now we have to specify the input shape. So we'll type input underscore shape, and it's going to be equal to 28 by 28 by 1. Then we need an activation function, and it's simply going to be ReLU. All right, now let's add a max pooling layer by typing layers dot here max pooling 2D, and then input a pool size of 2x2. Let's also add a second convolutional layer, so model.add layers dot conv2d, and then here it's going to be 56. The filter is going to be 56. The kernel size is going to be same thing. It's going to be a 2x2. And then we need, actually let's just add an activation function, and it's going to be ReLU as well. Now let's add a max pooling layer like this. So layers dot max pooling 2D and with a 2 by 2. And then we can simply okay, so yeah, that's it for the convolutional layers. We can run this. All right, now let's add one dense layer. But before that, since the convolutional layer returns a tensor of 2 by 2, we need to convert it into a one-dimensional tensor. And for that, we can add a layer that does that for us, and it's going to be um, a flattened layer. So let's just add layers dot flatten. And what this does just takes the two-dimensional output and converts it into a one-dimensional output that is compatible with a dense layer that we're going to add just right now. So we're going to be saying layers dot dense, and it's going to be 56 neurons with an activation function of ReLU as well, rectified linear. And finally, we need an output layer. So model.add will add an output layer. So we're going to be saying layers here dot dense as well. It's going to be 10 because our MNIST datasets has 10 digits from 0 to 9, each of them representing an output neuron, and the activation is going to be softmax, so that we get proportional outputs. Now we can run this like that. We can add a bit of code, and we're going to be compiling our model. So model.compile. Here for the optimizer, we're going to be using Atom. For the loss function, we're going to be using TensorFlow keras dot losses dot, and then here we're going to be using sparse categorical cross entropy, and then here from logit equals here it's true. All right, so let's compile our model, and it worked. And now we can train our model, so we say model dot fit. There we go. And then we're gonna fit the model on the training data, so xtrain. We're also gonna give it the correct output, so ytrain like this. The number of epochs are let's say 10, and validation data is, so here we need xtest and ytest. All right, so we can run our model here, and you should see the epochs running right here. All right, now the next thing I'm going to do is open up a program called GIMP and create a new window of a 28 by 28 pixeled image. And then I'm going to draw a number, and I'm going to draw a 6. Then I'm going to save the image as a PNG, and then use a software that I developed in my machine learning course for beginners to convert the image into its corresponding bytes. I'm then gonna copy the list of bytes and paste it in our program and save it to a x variable. After that, I'm gonna say x equals np.array of x to convert the list into a numpy array. After that, I'm gonna do the exact same thing as we did with the previous data, and it is dividing by 255. And after that, I'm going to do np.reshape, and I'm going to reshape x into a 1 by 28 by 28 by 1 to make it compatible with our neural network. Then I'm going to say predictions equals model.predict x, and then I'm going to save, I'm going to print the results, and for that, I'm going to use the argmax functions. I'm going to take prediction 0 because we only have one prediction. And what argmax does is it just gives us the location or the index of the greatest value. So predictions, basically, if you remember, we have 10 output neurons, and each of them has a value between 0 and 1, which is a probability of the neuron being the correct one. So basically, all we have to do is take the one with the greatest probability, take the index at that position, and the index is the number, because in the neuron 0 also corresponds to the hand digit 0, and neuron 1 is also corresponds to the hand digit 1. So basically, if we take the position of the neuron with the greatest probability, this also gives us the hand digits itself. And then all I have to say is print result dot numpy. All right, so that's it for our hand digit recognizer. As you can see, the model works pretty well, as it's able to predict the numbers that we draw. Make sure to subscribe, like the channel. Make sure to go check out our course for machine learning on our website, and we'll see you in the next video.